Hello students, welcome back to my YouTube channel Mathematical Lens by Namitha. In this video, we are going to continue with chapter number 2, Power Play of Grade 8 Mathematics of the new NCERT textbook Ganitha Prakash. And we are going to learn about scientific notation in this particular video. So let us look at some facts involving large numbers. You can see the sun is located at 3000000000. Oh my God! How will you read this? What happened from center of our Milky Way to galaxy? This is the distance of the sun from the center of galaxy, right? This is then the number of stars in our galaxy 1000000. The mass of the Earth is 59760000, some zeros and kg. Now, it is very difficult to read such large numbers. It is maybe you may decide and count it and read it properly, but it may take a lot of time and there are more chances of error. Also, it is very difficult to compare such large numbers, right? Time consuming, difficult, right? So as the number of digits increases, it becomes difficult to read the numbers correctly. We may miscount the numbers of zeros or place commas incorrectly. We will then read the wrong value, and it is like getting 5,000 when we were supposed to get 50,000. That would be a huge difference. So the number of zeros is more important than the initial digits in several cases. Like in this case itself, 5,000 and 50,000. 5 is same, but that zero has made the whole lot of difference, isn't it? So for convenience, there is a simple method devised for us to write the numbers, such large numbers, in a simple way, right? So that is what power play is about. Can we use the exponential notation to simplify and read this very large numbers correctly? So, like for example, like 5900, 5900, though it is very easy to read and understand, but we will learn how it can be simplified. So, the various ways of writing 5900 can be 590 into 10, 10 means 10 raised to 1, or 59 into 100, 59 into 10 square, or 5.9 into 1000, so 5.9 into 10 cube, for 1000 it is written 10 cube, or 0.59 into 10,000, 10,000 means 10 raised to 4. Now any number can be written as the product of a number between 1 and 10 and a power of 10. Now here we understood different ways of writing 5900. But if everyone writes in a different way, it will be difficult for us to compare again, right? So there are some rules which we need to follow for writing in the standard form or scientific notation. So all these numbers can be expressed as the product of a number between 1 and 10, means the value should be between 1 and 10, like this one. 5.9 is between 1 and 10, and a power of 10. So 5.9 into 10 cube, right? This is one way of writing. If it is 20,800, then 2.08 into 10 raised to 4. Now how do we get this 4? By counting after decimal point how many digits are there. 1, 2, 3, 4. You need to count zeros as well, right? Similarly, this is 80 lakhs. So 8, we decided that the number should be between 1 and 10. So 8, or you can write 8.0. And 10 raised to, how many zeros are there? 1, 2, 3, 4, 5, and 6. So 10 raised to 6, right? So this would make our work easier. We can easily read it. We can easily understand them. So write the large number facts we read just before in this form. So let us try to write down this The sun is located. So what we decided that the first number should be between 1 and 10. So 3 is there, so we write 3 as it is. And then we count the number of zeros. So what do? We can count in pairs, like your groups, like 3 plus 2, 5 plus 2, 7 plus 2, 9, 11, 13, 15, 17, 19, and this one 0 after 3. So 20. So 10 raised to 20. 3 into 10 raised to 20. Either you write 3 or 3.0, it is same. Similarly, the number of stars in our galaxy. So 1 into 10 raised to 3 plus 2, 5, 7, 9, 11. So 1 into 10 raised to 11. Now the mass of the earth, here digits are more, but that doesn't make any difference. You need to make it between 1 and 10. So we will write 5.976. All the digits other than 0 are to be written, but the decimal point should be after first number. So after 5, there should be a decimal point. And also count all the digits after the decimal point, right? So if we start from 0, 3 plus 2, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, and this one 24. You need to count till 9, right? So from 9 till this 0, you need to count. So that is 10 raised to 24, right? So this is how you write the numbers in scientific notations. So in scientific notation or the scientific form, which is also known as standard form, right? We write it x into 10 raised to y. Now what is important over here? X should be greater than 1 and less than 10. So it should be, the value should be greater than or equal to 1. It can be 1. So value should be between 1 and 10, less than 10, but 1 or greater than 1. So the values can be 1, 2, 3, 4, 5, 6 till 9.6, something like that, but not 10, single digit number. That is the coefficient of the expression, the scientific form. And y, the component, is any integer. This can be any integer, right? Mostly y is more important than x. Now, this is very important. Like the value of y is more important than x. Why is it said so? Let us understand. Now, when we write 2 crore population in Mumbai, right? And if we change the value of 2 crore means 2 into 10 raised to 7. So here, 7 is important or 2 is more important. What happens if these values change? If we increase them by 1, let us see. So, of course, 7 is more important than 2. Why? Because if 2 is changed to 3, 2 becomes 3 crore. Okay. 2 crore becomes 3 crore. But if 7 is changed to 8, the change in the population is 10 times. 2 crore becomes 20 crores. Right? So what was the basic? If I take 2 into 10 raised to 7, and if I make it 3 into 10 raised to 7, this is 3 crore. This is 2 crore. But if I change the value of power, this 7, so it becomes 2 remains the same. Okay. And 2 raised to 8. So this becomes 20 crores. See the difference. Here if I change this x, 2 becomes 3, so 2 crore becomes 3 crore. Not much difference. But if I change the power, because it becomes 10 times, 2 crore becomes 20 crore. That is why it is said that y is more important than x. Right? Therefore, the standard form explicitly mentions the exponent, which indicates the number of digits. Now, let us understand this same thing through more examples. Right? So, here the population of Kohima is given 1,42,395. So, it gives the impression that we are quite sure about this number, about the unit's place. Right? When we use such large numbers, in most cases, we are more concerned about how big a quantity or measure is rather than the exact value. Now, what will we do with such an exact value, right? We are only sure about that the population is around 1,42,000. That's enough, right? So instead of writing such a huge number, you can write it as 1.42 into 10 raised to 5, right? Which gives a fair enough idea about the population of Kohima, that it is around 1,40,000. Fine, we can write 1.42 or 1.4. There won't be much difference. So the number of digits in the coefficient reflects how well we know the number, right? This will be more precise. 1.42 will be more precise. And this will be less precise, but we will get an idea about the population of Kohima, right? So that is why in the scientific form, the exponent is more important than the first digit of the coefficient. The digits following the coefficient are small corrections to the first digits, right? They may not make much difference in while talking about them. So very interesting example here again is given to explain this. So there's a museum and a person asks, how old is this dinosaur skeleton? Right? So this lady is telling it is 70 million and 15 years old. Right? Now what? So why is she saying such an exact value? So she said that when I started working here, it was 70 million years old, and now I have been working since 15 years. So it is 70 million 15 years old. Now, for the age of dinosaur skeleton, this 15 year doesn't make any difference. Even 100 years will not make much difference. What is more important is this 70 million years old, right? So in large number context, the digits after the decimal point or after the first digit doesn't make much difference. What is more important here is 70 million than that 15 years, right? So now these values, they are rounded off, they are estimates, averages, or approximations, right? Most of the time they serve the purpose at hand, right? You don't need to know 15 years old, then you will talk about months and days, which is not necessary. Similarly, let us take one more example, which will make your concept clearer. Now see here the distance between the sun and Saturn. It is given as 143350, number of zeros will not count. Here it is given very precise in scientific form, 1.4335 into 10 raised to 12. Now here what is more important for us is 10 raised to 12. Again, the distance between the Saturn and the Uranus is again a very big number, which is converted into scientific form. So 1.439 into 10 raised to 12. And the distance between the sun and the earth is 1.496 into 10 raised to 11. Right? So can you say which of these three distances is the smallest? So as I told you, these numbers, x, the value of x is not important for us. What is important is the value of y. In these two cases, if you want to compare these two, then this value may be important. Otherwise, both are 10 raised to 12. But if we see this one, this is 10 raised to 11. So it is quite clear that this is the smallest. So which is the smallest? The distance between sun and earth, right? So you can look at the value of the power of 10, that is the value of y, and you decide that it is the smallest, the distance is the smallest, and that's enough in this context, right? Now you may feel that there is a difference of only power of 1. This is 1 is 10 raised to 12 and the other is 10 raised to 11. But that's not so. Here the number line shows below shows the distance between the sun and the Saturn, where the power, this is sun, this is Saturn. So here the power is 10 raised to 12. And the distance between the sun and the earth is 4.496 into 10 raised to 11. Right? So now on the number line below, mark the relative position of the earth. So this is very interesting. You will feel that there is a number of difference is only of 1, the power of 1. You need to show only 10 raised to 11. But that is 10 times difference. Means if you divide this distance into 10 parts, like if I divide it into 1, 2, 3, 4, 5, 6, 7, 8, 9. This is just approximate. They are not equal. You can use a scale and divide into 10 into. So where will the earth be? The earth is here, this position. 1.496 into 10 raised to 11, because the difference is of 10 times. The difference is 10 times. So that makes a huge difference when in talking in terms of power, right? Now there are some questions based on this. Express the following numbers in the standard form, right? So we just learned it. So we'll write the answer. Remember that the value should be between 1 and 10. So you need to put a decimal point after 5. So 5.9853 into 10 raised to 4, because here there are 4 digits. Correct? Similarly here 6.5950 into 10 raised to, again there are 4 digits. Don't forget to count the 0. So 10 raised to 4. Okay. Now the third question, 3.430000. So 3.43 into 10 raised to these 3 zeros and these 3 digits. So total 6 digits. So 10 raised to 6. Okay. And the last one, 7.004. Right? Till there are digits, you need to write them. And into 10 raised to, we count this 3 plus 2, 5 plus 2, 7, 9 and 10. We need to count till here. So 10 raised to 10. So this is how we write the scientific notation or the standard form. Okay. So we'll continue with this chapter in the next video. Thank you.